Okay, our next section is for special right triangles. The directions say to write down the rules for the special right triangles and then to use those special right triangles to solve for the indicated values. This is one of those situations where knowing these rules, these are shortcuts. This is supposed to make these problems faster and quicker so that you can quickly find and solve for these missing pieces. Now, the benefit of having a multiple choice test, such as the third 9 weeks test or the ACT, is that the answers are going to be there. Now, they're going to be written in simplest radical form. So it is easiest and quickest if you know these rules and you know these rules well. If you do not know these rules well, you can always use trig to either solve or to double check your answers. And so I'm going to be using these rules. So for the 45, 45, 90 triangle, remember that the legs are going to be congruent in a 45, 45, 90 triangle. The hypotenuse is always going to be equal to whatever your leg is. So for me in this picture, that's going to be x, and then it's going to be times the square root of 2. So x times root 2. For a 30, 60, 90 triangle, we have 3 different side lengths. So the short leg is going to be x. The hypotenuse is going to be double that every single time. So it's going to be 2 times x. And then the long leg is going to be equal to x times the square root of 3. And so you can see I've done that in this picture. If you are going to the hypotenuse, you're getting bigger, so you're going to multiply by 2. If you're going from the hypotenuse to the short leg, you're getting smaller, so you're going to divide by 2. So those are inverse operations. To go from the short leg to the long leg, across from 60, you multiply by root 3. What is the inverse of that? To go the other way, from the long leg to the short leg, you divide by root 3. So I am going to be going through these problems rather fast because if you know these rules, they're supposed to be a shortcut. If you don't know these rules, you could always use trig to solve, and you would just have to find the simplest radical form answers. You would type those in and see what they are as decimals. So I'm just going to go through this rather quickly. So the first thing I want you to notice in this picture, you need to decide, is this a 45, 45, 90 or is this a 30, 60, 90? This is going to be a 45, 45, 90 triangle, and I know that because both of these legs are 6. So since both of these legs are 6, how do I go to the hypotenuse? Well, I'm going from a short leg to the hypotenuse, so I'm getting bigger. So what I'm going to do is I'm going to multiply that by root 2. So what is 6 times root 2? That is simply going to give me 6 root 2. And I could have done that from either of the legs because those are congruent. Okay? What is this next shape? This is going to be a 30, 60, 90 triangle. I know that because I have a 60-degree angle and a 90-degree angle, so that makes this one 30. We always, always, always want to find our short leg because the short leg is our ticket around this triangle. So how do I go from my short leg to my hypotenuse? To my hypotenuse, I'm getting bigger, so I'm going to multiply by 2. So what do I get when I do 8 root 3 times 2? For x, that's going to give me 16 root 3. So I just double that whole number. 16 root 3 is going to be my hypotenuse. Okay, how do I go to my long leg? Well, to go from the short leg to the long leg, I'm going to multiply by, because I'm getting bigger, by root 3. 8 root 3 times root 3 is going to give me 8 root 9. What is the square root of 9? Simply 3. So 8 times 3 is going to give me 24. So y is going to be 24. Number 12. Number 12 is again a 30, 60, 90. A 30 and a 90, that forces this to be 60. So where's my short leg? It's all about the short leg. There's the x. The only number I currently have listed is the 14. So how do I go from the hypotenuse, which is 14, back to the short leg? Instead of multiplying by 2, I'm going to do the inverse because I'm getting smaller. I'm going to divide by 2. So what is 14 divided by 2? That is going to give me 7 for my short leg. If my short leg is 7, how do I get to my long leg? I'm getting bigger, so I'm going to multiply by root 3. So that's going to give me 7 root 3 for my long leg. So this is just simply using those shortcuts. So we're trying to make this fast. Number 13, what kind of shape do I have? I have a 45, 45, 90 triangle, which immediately means that x and y should be the same answer. So I'm going from my hypotenuse, which is currently 6, and I'm going back to a short leg, or I say short leg, back to a leg. And so what is the inverse of multiplying by root 2? I'm going to divide by root 2. So watch what happens when you do that. We have a radical in the denominator. So we're going to have to rationalize our denominator by multiplying by root 2 over root 2. This becomes 6 root 2 over root 4. So this is 6 root 2 over 2. We can simplify those whole numbers. 6 divided by 2 gives me 3 root 2. So both of my legs are going to be 3 root 2. And if you remember, we talked about figuring out that shortcut that a lot of people see, that if the Hypotenuse, y'all, that is a weird looking 3. I'm sorry, I've got to fix it. It's bothering me. Okay, so if the hypotenuse is a whole number in a 45, 45, 90 triangle, each leg is just going to be half of that whole number times the square root of 2. All right, so this one is also a 45, 45, 90. So both of those legs should be congruent. So to go from the hypotenuse to a leg, we're going to divide by root 2. So let's see what happens on this one. I do have a radical in the denominator, but unlike the previous problem in number 13, I have a radical that I can cancel that out with. Those are both root 2's. So what are both my legs going to be? Both my legs are going to be 5. So x is going to be 5 for each of those. Number 15. 15 is also a 45, 45, 90 triangle. So x and 16 should be one and the same. X is going to be 16. Those are the legs of a 45, 45, 90 triangle. How do you go from that leg to the hypotenuse? I'm getting bigger, so I'm going to multiply by root 2. So my hypotenuse is going to be 16 root 2. Number 16, I've got a long leg and I want to get to the short. This is a 30, 60, 90 triangle. So in a 30, 60, 90 triangle, how do I go from my long leg back to my short leg? I'm getting smaller, so I'm going to divide by root 3. So let's see what happens. It's going to be 8 root 3 over root 3. The root 3's cancel, and my short leg is simply 8 for B. If my short leg is 8, how do I get to my hypotenuse? It's getting bigger, so I'm going to multiply by 2. 8 times 2 gives me 16 for A. Number 17 is a 30, 60, 90 triangle. Again, I need my short leg first, so how do I get it? I'm going to go from my long leg back to my short leg. And to do that, you divide by root 3. So that's going to be 6 root 3, 6 divided by root 3. And now we need to rationalize that denominator. So I'm going to multiply by root 3 over root 3. What ends up happening is you get 6 root 3 over root 9. Well, what is the square root of 9? It's a perfect square, so it's going to be 6 root 3 over 3. 6 divided by 3 simplifies to 2 root 3. So my short leg is 2 root 3. That is not an easy problem to do. So that is my short leg. So how do I get from my short leg to my hypotenuse? I'm going to double it. So what is 2 root 3 times 2? That is going to give me 4 root 3. So 4 root 3 is x, and then 2 root 3 is y. Number 18, last but not least, is another 30, 60, 90 triangle. So for my 30, 60, 90 triangle, it's all about the short leg. That's my ticket around this thing. So if that is 5, how do I get to my hypotenuse? I'm going to get bigger. I'm going to multiply it by 2. So A is 10. How do I go from my short leg to my long leg? I multiply because I'm getting bigger by root 3. So that's just going to give me 5 root 3. And so on each of these problems, we were asking ourselves, what kind of special right triangle is it? And then we were just using those rules, 45, 45, 90. And then this one was a 45, 45, 90. And we were using those shortcuts. They're intended to be shortcuts. And then if you could not do it this way, you could always use trig in order to solve for a variable as well. Obviously, 5 root 3 is not how you're going to get the answer in your calculator. If you type in 5 root 3, you get 8.66, and it keeps going 0, blah, 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 blah. You could always, on a multiple choice test such as the ACT or a third 9 weeks test, you could always use trig. So like, for instance, on this one, I could find A, I could do opposite and hypotenuse. That would be the sine. I would still get 10. To find B, I'd have opposite and adjacent. I could use tangent. I would still get the answer. I would get it as 8.66, but that would be written in the form as 5 root 3, so you could type those in to see what that would be as a decimal. So that is number 10 through 18, which is our special right triangles.